All right, we're going to look at what is a thermochemical equation. So a thermochemical equation is a balanced chemical reaction that includes an energy term within either the reactants or the products. We are going to look first at the thermochemical equation for photosynthesis. So photosynthesis is 6 carbon dioxide molecules plus 6 water molecules plus an energy term. And that energy term is 2,802.5 kilojoules. And this together produces glucose, so C6H12O6, and 6 oxygen molecules. In this equation, you'll notice that the energy term is on the reactant side. That means that this is an endothermic reaction. So our reactants are gaining energy from the surroundings and storing it as potential energy in the product. We're now going to look at cellular respiration, which is the opposite of photosynthesis. So we start with a glucose molecule. To that we add 6 oxygen molecules. And we form 6 carbon dioxide molecules, 6 water molecules, and energy, specifically the same amount as we used in photosynthesis, so 2,802.5 kilojoules. This time our energy term is on the product side, making this an exothermic reaction, so our products release energy during the reaction. So the thermochemical equations that we've written here, the energy terms are specific for the equations that we've written. So here we have 2,802.5 kilojoules of energy. That is if there's 6 moles of CO2, 6 moles of H2O reacting. So for every 6 moles of CO2, we use 2,802 kilojoules of energy. For every 6 moles of H2O, we use 2,802 kilojoules of energy to make 1 mole of glucose or to produce 6 moles of oxygen. So again, those coefficients are specific to that amount of energy written in the thermochemical equation. We're going to look at what happens when we change the coefficients of our chemical reaction. So we're going to recall photosynthesis. So I'm going to start by writing the balanced thermochemical equation for photosynthesis. So 6 carbon dioxides plus 6 waters plus 2,802.5 kilojoules of energy forms 1 glucose molecule, or 1 mole of glucose, and 6 moles of oxygen. So it's important to understand that this term, this 2,802.5 kilojoules, means that we require that much energy. So we require 2,802.5 kilojoules per, and so that's per 6 moles of CO2, per 6 moles of water, per 1 mole of glucose, and per 6 moles of oxygen. So what would happen if we were to produce 2 moles of glucose? So we can look at how much energy is required to produce 2 moles of glucose. If we make 2 moles of glucose, we're going to use this value, this 2,802.5 kilojoules per 1 mole of glucose from our balanced reaction, and we're going to multiply that by 2 moles of glucose. So what that's going to do is if we make 2 moles of glucose, we're going to need 12 moles of CO2. So we're going to double everything. We're going to need 12 moles of H2O. And we're going to need 2,802.5 times 2. So we need 5,605 kilojoules of energy to create 2 moles of glucose and 12 moles of oxygen. So because we've doubled the coefficient, we had to double the energy term. We're going to go through an example now. So in a balanced thermochemical equation for the combustion of 1 mole of methane is 1 mole of CH4 plus 2 moles of O2 plus 1 mole of or produces 1 mole of CO2, 2 moles of H2O, and 802.5 kilojoules of energy. So write the thermochemical equation for the combustion of 3 moles of methane. So to start, we're going to write our energy terms. So we have 802.5 kilojoules of energy for every 1 mole of methane. And so that 1 mole of methane is from the reaction itself. We're going to multiply this by 3 moles of methane. And we find out that the energy term is now 2,407.5 kilojoules of energy. So we can now multiply the coefficients for all of our reactants by 3, as we've multiplied the coefficient of methane by 3. So this is going to give us 3CH4 plus 6O2 produces 3CO2 plus 6H2O plus 2,407.5 kilojoules of energy. Our second example is the balanced thermochemical equation for the combustion of ethane is 2 ethane molecules plus 7 oxygen molecules forms 4 carbon dioxide molecules plus 6 water molecules and 2,856.8 kilojoules of energy. Write the balanced thermochemical equation for the production of 12 moles of H2O. So that 2,856.8 kilojoules is for 6 moles of H2O. So we can start by writing our 2,856 kilojoules, so 56.8 kilojoules, and that's going to be divided by 6 moles of H2O, and that's just the coefficient from our reaction. Now we're going to multiply that by the number of moles of H2O we want to find. So that's going to be 12. So we've just solved for molar enthalpy. And we're now going to multiply by 12. So we have kilojoules per mole. And we're going to multiply that by 12 moles of H2O to get the energy change in that scenario. Our moles here will cancel. And we're left with 5,713.6 kilojoules. And so if we double the coefficient of water, so we go from 6 to 12, we're going to double the coefficients of everything else within that reaction. So our new thermochemical equation is going to be 4 ethanes plus 14 oxygens plus produces 8 CO2s plus 6 waters, plus 12 waters and 5,713.6 kilojoules of energy.